This is probably the most important content for the future of humanity that you'll see today. The reason is simple. I want to show how an artificial intelligence programmed to be benign and have only the best intentions can paradoxically annihilate humanity. I'd like to start this video by discussing something you're probably familiar with: Isaac Asimov's 3 laws of robotics. These laws are present in many of Asimov's stories, especially in the book I, Robot, where he explores these laws deeply and finds limitations for each of them. The idea of the book is precisely to demonstrate that all laws have limitations and can present flaws that could cause even worse problems than those they try to avoid. The 3 laws are as follows. First law: a robot may not injure a human being or, through inaction, allow a human being to come to harm. Second law: a robot must obey the orders given by human beings, except where such orders would conflict with the first law. Third law: a robot must protect its own existence as long as such protection does not conflict with the first or second law. Later, Asimov introduced a 4th law called the 0th law of robotics, which would be above all the first 3 laws. The 0th law states that a robot may not harm humanity, or by inaction, allow humanity to come to harm. These 4 laws, at first glance, don't seem to have serious problems, and it would make sense to think so, as when we say that a robot cannot harm humanity, it's almost impossible to imagine a situation where this would be contradictory. However, if you have followed Asimov's work, you already know that there are several ways in which these laws can contradict each other, with disastrous results. It's curious that, in some of his stories, one of the solutions would be to relax some of these laws, allowing the machine to make decisions more freely. The dilemmas presented in Asimov's books and stories seemed confined to science fiction issues. After all, that was the genre in which he wrote. At the time he wrote these stories, the idea of having robots with intelligence superior to ours walking around seemed like something that would take a long time to happen, if it ever did. But what if I told you that we are currently dealing with a problem very close to the one addressed by Asimov? We have not yet reached a point where super-intelligent robots have become a reality, but the problem has already become a current challenge. I would like to make an important observation. So far, we have referred to these intelligent machines as robots because that was Asimov's approach. However, this denomination is not entirely accurate, since robots evoke the image of humanoid beings with metal parts like those we see in movies and series. The problem we will address in this video goes beyond these robotic humanoid beings. We are talking about more accessible devices already present in our daily lives, such as your cell phone or, at this very moment, the website where you are watching this video, which uses a recommendation system algorithm. Therefore, it is crucial to clarify that in this context, robots refer to machines that could even be your cell phone or your laptop. And this is precisely what makes the problem even more serious than Asimov imagined, because we do not need to wait for a humanoid robot to face it. Before continuing, I would like to ask you to share with your friends, like the video, and subscribe to the channel. It helps me a lot. Returning to the video, let's assume you are hired by an artificial intelligence company that has developed an extremely powerful general artificial intelligence, AGI. This AGI has intelligence far superior to any human and can do everything a human can, but much faster and more efficiently. The company asks you to determine what values and rules this AI should follow. Should it aim for the good of humanity? Should it solve serious problems like hunger or wars? Should it research new medications that could cure cancer? Should it not harm a human being? All these rules and values are in your hands. What rules and values would you define for this artificial intelligence? Here you are already encountering some problems because your values may not be the same as mine or those of other cultures. But before we get into those points, let's focus on one that will start our entire conversation, and I hope that, by the end of the video, I can convince you of how big this problem can be. Let's suppose you decide that world hunger must end and set a rule that no human being should ever go hungry again. You send this guideline to the company and they implement it. A few days later, you read in the news that humanity is being exterminated and that some populated regions have ceased to exist. The AI you thought was helping is cutting off electricity, diverting ships and planes, cutting off supplies from all places, causing a real chaos that will soon lead to the extinction of humanity. You wonder what went so wrong and contact the company that developed this AI, who responds that this was a consequence of your choices and that humanity paid for it, going extinct. This is the moment when you finally have the click in your head and everything starts to make sense. You wonder, what did I do wrong? When you asked the AI to solve the problem of hunger, you said that no human being should ever go hungry again. But human beings only go hungry if they are alive. That is, no human being will go hungry if humanity does not exist. This was a very simple line of reasoning for the AI, and it is probably fulfilling its role without even understanding what it is doing. We cannot deny that the problem was really solved if humans no longer exist. You might be thinking of ways to circumvent this and even communicate with the AI to avoid this disastrous solution, but I assure you that you will always reach some dead end. It may not be something as obvious as in this case, but when it comes to artificial intelligences, you will encounter problems, from the simplest to the complete extermination of humanity. And this problem has a name: the alignment problem. The alignment problem can be summarized as the challenge associated with building powerful artificial intelligence systems in such a way that they are aligned with human preferences and interests, avoiding undesirable or harmful consequences. We want artificial intelligence to do something, which can range from something simple, like deciding which YouTube video you will watch, to extremely complex situations, like solving the great problems that humanity faces. A problem similar to the thought experiment I just did with you was proposed in 2003 by a philosopher from Oxford named Nick Bostrom. In his version of the problem, we create an artificial intelligence whose only function was to increase the production of paperclips. This AI is much smarter than us and comes to the conclusion that eliminating human beings is the solution to produce more paperclips, since it could transform human body atoms into paperclip atoms. We realize this error and decide to simply deactivate this AI. But as it would be programmed in a high-preservation system, it starts a kind of war with human beings while producing more clips. Can you see the contradiction that the problem leads to? While it does something we asked for, produce clips, it fights with us, possibly leading to our own extinction. Bostrom concludes that as this AI would be much smarter than us, it would possibly win this war against humanity. And it would not even be doing something objectively wrong from its point of view, it would just be succeeding in its function of making more paperclips. The problem of Bostrom is even more extreme, but it shows that you do not need to try to solve world hunger to reach serious consequences. Something simple like the production of clips could lead us to a disaster, and that's where the alignment problem becomes obvious. If we need to define a goal for artificial intelligence, we need to be 100% sure that this goal is exactly what we want. Some experts, like Yoshua Bengio, winner of the Nobel Prize in Computing, Geoffrey Hinton, the fathers of artificial intelligences, and even Alan Turing, already indicated that a misaligned AI would be catastrophic, and we would only have one chance to obtain an AI with superintelligence, one chance to get the values and ethics of this artificial intelligence right, because it is literally a path with no return. Do you remember any recent problem we had with AI? Something like this happened in 2018 when the Uber company made autonomous cars available. The AI behind these cars was trained with various data, like red light means you should stop, data of person recognition to avoid running over people, or recognition of other cars. The goal of the autonomous car was to drive in a safe way, avoiding pedestrians and other cars, and avoiding an accident as much as possible. In 2018, there was an accident with one of these cars, which ended up seriously injuring a person, eventually leading to death. When they investigated the conditions that led to the accident, they discovered that the car was prepared to avoid pedestrians in pedestrian crossings, but not reckless pedestrians crossing the street anywhere. More than that, the AI had been trained with data of people riding bicycles, or even bicycles alone, but it had no knowledge of a person walking on the street with a bicycle by their side. Since it could not interpret what that was, the machine could not take action, and by protecting what it knew as other cars driven by other people and other pedestrians, it was involved in an accident. This shows one of the main points of the alignment problem: the data that machines learn. When we talk about artificial intelligence today, we almost always refer to machine learning. Machine learning is when the machine learns to observe a large amount of data, and all its learning is associated with the content being displayed in this data. In the case of Uber, the lack of images of people holding a bicycle on the side of their body was enough to cause the death of a person. Something similar happened at Amazon, where the lack of data from women's resumes made the AI created to analyze resumes always end up choosing resumes from men. Since the AI learns from the data, it is from there that it will make its decisions, and the lack of data or data considered bad can cause problems. The issue of biases that data can place results in a goal that may not be exactly what we want, and this is something that lacks in machines, the notion of what should or should not be done. This can even vary for different people. Imagine that you are completely against the use of elevators and argue that elevators are dangerous because many people have already died falling from them. But there are people who believe that elevators are a very good tool and should not be banned because many people who do not have the conditions to climb stairs can get where they need to. This is a very simple example, but it makes us visualize the question well. Which of these beliefs and values should be placed in the AI? Remember that this varies even more when you go to countries with different policies and cultures. It is impossible to say which should prevail in the end because there is not one that is superior to the others. Would you really want the values and beliefs of other people to be imposed on you through these machines? Another way to avoid this is through the algorithm itself, which will be trained with the data. An essential part of learning is the loss function. But we can also say that it is an error function that quantifies how wrong a result of an artificial intelligence is. Brian Christian, who wrote the book The Alignment Problem, cites in his lecture about the problem associated with these functions that this is not a simple task and has several layers that need to be resolved to solve this problem. How should we quantify the error? Are all errors the same? How can we make it penalize more when the error can be catastrophic? The way we implement this error function is precisely the way the AI will learn and penalize. Besides the data, the function we implement within the code will define the actions that model will take in the future. In other words, our biases are there, and even biases we do not know we have. Maybe I can even change the question: how to quantify the success of a model? What does the success of something mean? A current example that combines these two problems is what happened with the Google Photos classification model in 2015. A web developer named Jackie Al-Sine posted photos where he and his friend appear together, and the company's classifier placed the class perilous for the photos. This shows how the model was flawed, even lacking ethical values to combat a racist attitude, probably due to the bias of the data and the lack of care in implementation. Right after this case, other errors were found with the classification of Google Photos, like confusing cats with lynxes or bicycles with motorcycles. But none of these errors is as serious as the first, which even made national news in the United States. When this type of problem occurs, we can scale it as a problem of recognition and classification in situations that can cause injustices and even errors that can lead to more serious consequences. What I mean is that errors are not all equal. We, as human beings, can understand why a case of racism is more serious than calling a bicycle a motorcycle. But how do we pass this logic and these values to an artificial intelligence that does not possess them? How do we build an error function that understands that there are errors more serious than others, and that it is not possible to treat them all as equals? In other words, how do we convey the idea of what is right and wrong to an artificial intelligence? And the question becomes even deeper when we realize that we ourselves are flawed in these issues. The worst of all is that these are problems that are already happening and are machines that are increasingly being implemented in our lives. The ChatGPT is a perfect example of a tool that learned from various data and that is entering various branches of our life. So, how do we pass our ideal of values to ChatGPT? We have already discussed two of the main problems within the alignment problem: the use of data and the construction of the algorithm that will be trained. We could spend hours just finding increasingly sensitive details that could lead to the creation of something catastrophic and consequences we cannot imagine. But the alignment problem is precisely the question of how to ensure that artificial intelligences will do what we want without being harmful? And is what we want necessarily what is best? And if not, how do we prevent the artificial intelligence from making that decision for us? These are questions that involve not only computer scientists, but also philosophers, doctors, sociologists, economists, physicists, chemists, and biologists. This set of questions is something that all of us should be asking ourselves, even as we use tools like ChatGPT. As I said at the beginning of the text, we only have one chance before a point of no return. How can we ensure that this chance is something we want, and that our last invention is not also the end of everything we know? I would like to know what you think about this in the comments. Thank you very much, and see you next time.